In the previous lessons, we have talked about a line. Let's just review that very briefly here. So let's make it look like this. So we talked about a line, and a line kept on going in both directions. All right, then we talked about a line segment. And a line segment, it started and it stopped, about like that. We call these 2 points on the end endpoints. Notice there's no arrows here, so it doesn't keep on going forever. These 2 ends keeps on going. They keep on going forever and ever. This starts and it stops, or it starts here and it stops here. Okay, there are ends to it. Well, we have another figure that we're going to learn for the first time today, and that it looks like this. It's kind of like a combination between the two. That's why I wanted to draw them both. Now, it doesn't have to go horizontally, but I just drew it like that. Watch what it does. It keeps going at one end, but then it has a beginning. And what did we call these points right here when we had a line segment? We call them endpoints. And guess what this is going to be? That little point right there is also an endpoint. And it keeps on going, so that keeps on going forever and ever. This thing right here, this is a line. This is a line segment. This right here is called a ray. And that's what we call it when it has a beginning and it keeps on going just in one direction. This keeps going in 2 directions. This starts and stops. It doesn't keep on going forever in either direction, but this one, in this particular direction where the arrow is pointing, it keeps on going forever and ever, and we call that a ray. Now, we need at least 2 points on this ray in order to identify it. So let's call this one, we'll use the same letters they use in the book. That's an M. And let's put a point right here. Let's call that O. And let's actually put 3 points on this ray. And we'll call that point P. So this is a ray. And how do we name it? Now we have 3 points. And if you remember up here, how do we name this? If I put A and B, I could call it line AB, or I could call it line BA. Same thing with this. If I call this PR, I could call it line segment PR, or I could call it line segment RP. It didn't matter the order, but on a ray, it absolutely matters what order you put these in. Remember, we only picked 2 points. Even if I had a C in here, I would still only choose 2 points. Same thing here on a ray. I'm only going to choose 2 points, but it absolutely matters what order you put these things in. Now, remember what I said to this. This is an endpoint, but this is basically where your ray starts. It starts right here, and it keeps on going in that direction. This starting point, now I know we called it an end point, but it doesn't mean it ends there. It just means a point on the end of the ray, right? But this is, let's say, where we start, and it keeps on going in that direction. We have to start with the end point as our first letter. So if I'm going to call this a ray, I have to start with the end point being first. It absolutely makes a difference what order you put these in. But now, I don't care how many points I have on this ray, I have to start at the end point, but then I can choose any of the points that this ray goes through. Remember, it doesn't stop at O and it doesn't stop at P. It keeps on going through. So I could have half a dozen points on here, and I would just pick this as my first one, and then I can pick any of the other points as my second point. I'm only going to use 2 points, so I can either pick the O or the P. So I could call this ray MO, or I could call this ray MP. Now we have a symbol. For instance, if I call this line AB, it doesn't look like a B. Let's try that again. That's a little better. I would put a line symbol over top of it, arrows in both directions. This one, whoops, we're not using A and B this time, are we? Let's go PR. I would just put a line segment over top of it, no arrows on this one. But since this is a ray, what we're going to do is kind of make it look like this. It's not going to have arrows on both ends, it's only going to have arrows on one end. So we're going to make it look like this. So that would be the symbol for ray MO. This would be the symbol for ray MP. I'm going to put an OR in here because I could call this either one. It's exactly the same ray because it doesn't start and stop. It does start right here, but it goes through. So if it goes through O, it's eventually going to go through P. Do you see it doesn't make any difference what we call this? I could call this ray MP or I could call it ray MO. One thing that I cannot do on this that I did up here was switch the order of the letters. I can't call it ray OM because that would mean it starts at O and it goes through M and it keeps on going. But is that what's going on with this ray? No, it's not. It starts at M, it goes through O, keeps on going through. You can have a whole bunch of letters in here if you want, but it keeps on going through all those letters. I only picked 2 letters, and the first letter is very, very important. Okay, I have to use the endpoint for that first letter. All right, so I hope that makes a little bit of sense with array. Now let's do this. Let's draw. It's going to look like a line. So we're going to have arrows on both ends. And watch what I'm going to do. I'm going to put a point right here. And let's call this, using the same letters in the book, H, J, and K. So we're going to say H, J, and K. All right, so there's line. Now, if I was going to name this line, I would say it's line HJ, or it's line JK, or it's line HK, or I could reverse the order. Okay, I wanted to just name it by the line. But what I want to show you here is that a line is actually made up of two rays. If you look at it, if I broke it down, okay, watch, I'm going to put a little dotted line right here. I actually have two rays. I have a ray going this way, starting at J, going through H, and I have a ray going this way, starting at J and going through K. Now they're going in complete opposite direction. All right, it's a complete opposite direction, and so since both rays are going in opposite directions, I call them opposite rays. So these two would be opposite rays. So if you had a question that said, name the two opposite rays, what would you name it? Well, one of them would be JH, ray JH, because it starts at J and it goes through H and it keeps on going in that direction. Or I could call it, or I'm sorry, the other ray, the other opposite ray would be JK. So JK would be that way. Now, just because this ray goes to the left doesn't mean we put an arrow to the left. Our symbol for ray always looks like this. The arrow always points to the right, no matter what direction our actual ray is actually pointing. Sometimes people get confused on that. So these two right here, they're not the same ray. They're two completely different rays. They are opposite rays. I'll just shorthand that. Okay, so they're opposite rays. All right, let's continue some more. Let's talk about a couple other rays. But these are not opposite rays. I am going to have two rays. And let's make it look like this. Now, if you look at that, there's one ray, starts at that point right here. That's the end point. It keeps on going this direction. That's one ray. And there's another ray. It starts at that same end point. Both of these rays share the same end point, but it goes in this direction. So they're not opposite rays because they don't go in the complete opposite direction. But I do have two rays that share a common end point. This is the end point for this ray. It's the end point for this ray. Now, what have I formed right here? You might have talked about this stuff before. But what is this? You probably know that already. Well, we call that an angle. So an angle is actually the combination of two rays with a common endpoint. That's what a ray actually is. And we have some words to describe some things in here. This point, this common endpoint that they have, is called the vertex. We mentioned that in one of the other lessons. We talked about that word vertex. So that's the vertex of the angle. It's where the two rays come together. They meet at that one point. That's called the vertex. And then you also have the rays themselves. So this actual ray right here is called the side of the angle. And this one is also the side of the angle. All right, so those are just kind of descriptions. They kind of just break down the angle and they talk about what the names of them are. Well, let's name this angle. Let's put some letters in here. And I'm going to put a point right here because remember, a ray is made up of 2 points, the end point and a point that it goes through. So I don't know, let's just call this A. We'll call this B, and we'll put another point over here, and we'll call this C. So if I wanted to actually name this specific ray right here, there's a couple ways you could do it. One way is you can use 3 points. Since I have 2 here, and this is the same letter, I can use those 3 letters. But just like the ray, you have to have the end point being first. Remember that? On an angle, this vertex always has to be in the middle. And we have a symbol for angle as well. And it kind of looks like the shape of this particular angle that I drew. So here's the symbol for angle. See, it looks like an angle, just like this angle right here. And what do we call it? Remember, the vertex has to be in the middle. And in this one, it doesn't matter what order I go in. I could go angle B, A, C. All right, I'll write that down. Or I could go angle C, A, B. I'll write down or, angle symbol, C, A, B. What was true about both of these? What do they have in common? Well, they have this vertex in the middle. See that? That has to be in the middle if you're going to name this angle. So if I'm going to use 3 points to name an angle, I have to have the vertex in the middle. Okay, so the vertex has to be in between those other 2 points. And it doesn't matter what order I put them in, BAC or CAB. All right, so that's a little bit about an angle. I'll keep the same picture up here. We can also talk about points that are inside the angle and outside the angle. See how this angle's like this? Anything in here would be inside the angle, okay? Or if that's supposed to be shading, by the way. So if I put a point right here, I would say that's inside the angle, but we get a little bit more technical than saying inside. We say it's in the interior. This is the interior of the angle, okay? It's inside the angle, right? And what would it be out here then? Out here would be the exterior. Yeah, a lot of vocabulary in geometry, okay? Sometimes it's like its own language. So this point right here would be in the exterior of the angle. This point, this blue point right here, would be in the interior of the angle. What about actually B, A, and C? Well, they would be on the angle, on the angle. All right? I think that makes a little bit of sense. Let's see what else we want to do. Okay, we can actually measure these angles. You know how we measured the line segments and we measured it in centimeters and inches? We can measure an angle as well. Okay, here we have an angle, and what I want to do is I want to measure that angle. So what do we use to measure an angle? Well, first of all, let's talk about the measurement first of all. We measure angles in things called degrees, and I'm sure that you've probably heard of that. We're not talking about the temperature. 100 degrees outside is very hot, Fahrenheit anyway, 0 degrees is very cold. We're not talking about that kind of degrees. What we've done with this angles, we've taken 360 degrees. If you go around a whole circle, that's 360 degrees. You've probably heard of that like on television if they do like skateboarding, or in the Winter Olympics especially, they do what's that thing? Not the skiing. I guess they do skiing and snowboarding and that kind of stuff. Okay, and they talk about, wow, he did a 3.7 or a 360, or he did a 540 or a 720. What numbers are they talking about? They're talking about degrees. How many degrees did they spin around? A guy dunking a basketball, he does a 360 degree slam dunk. Okay, that's degrees. But when we talk about angles, it's kind of the same thing. 360 would be all the way around, so from here to here would be less than all the way around. If you go straight up and down, okay, that would be a quarter of all the way around. If you took this and you stretch this out right here, you go halfway around, 3/4, and all the way around. So what we do is we measure from here and we go to here, and it's how many degrees. All right, and we have a little device that helps us measure how many degrees, and that is called a protractor. Protractor. Okay, and I just happen to have a protractor right here. How about that? Let's scooch this down a little bit. Now, on this protractor, it's not see-through, so I can't really use this online protractor to measure that angle that we had up here. Okay, it would be pretty difficult. The protractors that we would have in class would be see-through, and you can put it right on top of your angle, and you can see the degrees. Let's take a look at the numbers here. This spot right here is where you would put on the vertex. The angle comes together right here. That's your vertex, and you would measure the degrees from there. So watch. If it goes just straight out, that's 0 degrees. Now you also have 180 because this could be stretched the other way. As you notice, you got 2 sets of numbers all the way around. Look at the inside numbers. It's 0. That would be 10, 20, 30, 40, 50, 60, 70, 80. And then 90 straight up and down. Remember, that's 1/4 of a circle. So 360 divided by 4 would be 90. That would be 90 degrees. And then watch, it gets bigger and bigger. If we stay in the inside, 100, 110, 120, 130, all the way down to 180. That's because we started at the left, or started at the right, sorry, and moved to the left. We moved counterclockwise. What if you started at the left and you moved clockwise? Well, this would be 0, then it would be 10, 20, 30, 40, 50, all the way around. It's 90 either way you go. And then it's 100, 110, 120, 130, all the way to 180. So we have to figure out the degree of this angle. So if I was to put the vertex of this angle right on tell you what I might be able to do is put this, let's group it. I hadn't thought about this until right now. I might be able to actually take this and put it on top. I was thinking about putting the protractor on top of the angle. Let's see. I think it's behind. Let's arrange, move to front. Yeah, there we go. Okay, yeah, that's pretty good. Look at that. I hadn't thought of that before. I just figured that out. So if you take a look at this, I put the vertex of the angle right at that crosshair mark, right there on the vertex where all 4 lines come together. And we put it right here. Make sure that the 0 degrees lines up right with one of the sides of your angle, and then watch how much it goes up. So your angle starts here and it goes up to here, and how many degrees is that? Now, which one are we using? Are we using this big number or the smaller number? Well, we started at 0, 10, 20, 30, 40, so we're using the smaller number. So there's 40, and it looks like it's not quite 45, maybe 44. So I would say this angle right here would be 44 degrees. Let's try another one with that protractor, now that I figured out how to use it. Now I'm going to show you something else. And I had that saved because I thought, oh no, I'm not going to be able to use this protractor, but now I figured out how to do it. So actually, yeah, we'll keep this behind because this is, and then what do I have to do? I have to put the vertex right at the crosshairs of that protractor right there. Now, if you go this way, it's opened up real big. See, it's opened all the way to 90 and past 90. So I'm going to start at 0. So if I start at the right side, I go 0, 10, 20, all the way to 90, 100, 110, all the way to, let's see, it doesn't quite get to 130, does it? That little line right there looks like it'd be 130. So this would be about 129. So this angle right here is about 129 degrees. Now, if I wanted to, and let's say I extended this bottom line out like this, I could figure out what this is right here, this angle. So you could just start at 0 and go up to here. And where is it? It looks about, remember, we're starting at the smaller numbers, 0, 10, 20, 30, 40. And it's 50 is here, and it looks like it's about 51. So that would be 51 degrees. Well, check this out. What is true? Let's see the relationship between 129 and 50. Well, that's actually 180 degrees, and it should be, because if I start here and go all the way around to here, let's do that in another color. So if I started here and I went all the way around, oops, messed up, try it again, all the way around to here, that is 180 degrees. So if you're looking this way and then you turn to look this way, how many degrees did you turn? You went 180 degrees. I got a little website right here. Let me bring that up just to kind of give us a little practice. Let's give this a shot. So I just found this online, and this is kind of cool, where you can actually take the protractor, move it around, and put it right here. But before we do that, let's kind of guess what we think this angle is going to be. So angle ABC. Now they give you 2 choices for 65, not really sure why, but what do you think this is? Do you think it's 65 or 157? Wow, I don't think it's 157, because remember, if we go to here, that's only 90. This is less than 90. I really doubt it's 157. Let's put the protractor on here and see where it comes together right there? That's where we want to put onto our vertex, and we want to make sure that that 0 degrees lines up with one of our angles as well. So look at it. 10, 20, 30, 60, what? 5. So I'm going to click 65, and look at that. We got it. Pretty cool. Here's another one. What do we think this is? Now, we got 58, 55, and 0. Well, it's definitely not 0, but 58 and 55, I don't know if I can just look at it and determine what it is. So I'm going to use my protractor, move it over, put it right on top like this, and where is it? Yeah, it definitely looks closer to 60, doesn't it? So it doesn't look like it's dead in the middle. So it's probably not 55, it's probably 58. And we are correct. Look at this angle right here. Now this, if I went straight up and down, that would be 90, wouldn't it? So this looks like it's a little bit more than 90. So I could probably just guess. Not just guess, but I could probably just eyeball it, right? And look at, it's not 84, because 84 would be on this side of the 90. 141, nah, it looks like it's a lot closer to 90 than it is 141. So it's probably 95. Well, let's put the protractor on here. And let's see. Sure enough, look, there's 90, and it's halfway between 90 and 100 and 95, and we got it right. All right. So what about this one? Let's just eyeball it and not use the protractor. 120? No, 120 would be more than 90. 144 would be more than 90. So it's probably 69. I'm just curious. We're not going to go through any more with this, but I'm just curious. Let's just, for fun, try one of the wrong ones to see what it does to us. Oh, it's pretty nice, and it just says try again. I thought it would be a big old thing yelling at you or something. I don't know. But it says just try again. So we knew it wasn't 144. We know it's 16, or it's 69 degrees, and there it is. Oh, they changed the angle, sorry. Yep, and they said, you are good. Pretty nice. What about this? Now, this is too close. 34 and 33, I can't just look at this. I definitely know it's not 143. So 33, 34, it could be any of those. Let's put this on here to maybe help us out a little bit. Looks like it's about right there. It looks really close to 30, doesn't it? I'd probably say 33. Let's see. Yep, we got it. What about this one? It's definitely not 80. It's probably 134 or 130. Again, it's too close to just tell. So I'm going to use my protractor. And let's put it, let's see. It looks like about right there would be a good spot to put it. And yeah, it's definitely 130. It hits it right on. 134 would be about in here somewhere. So I hit 130 and we got it. You get the idea. Let's go back to this. Okay, I've drawn a few angles here, and I just want to name them very quickly. I want to try to get this finished pretty quick here. Now, if you look at this, that would be 0 degrees, and this is straight up and down. Remember where that was? It was 90. We show this box. Instead of actually putting a 90 up here every time, we use this little box to indicate that it's a 90-degree angle. And we also call a 90-degree angle a right angle. And our symbol for angle is that thing right there. Okay, so this is a right angle, and it's equal to 90 degrees. If you come down here, this angle right here, is it less or greater than 90 or equal to 90? It's definitely not equal to. We just saw it with what was equal to 90. It's not more, because it would stretch out like this. So this is less than 90. We call this an acute angle, A-C-U-T-E. It's an acute angle, and that would be less than 90 degrees. And we have another type of angle. If you look at this, this is more than a 90-degree angle, and we call this an obtuse angle, and that would be more than 90 degrees. In fact, on Facebook, somebody said something about an acute angle. Oh, look how cute it is, or something like that. Anyway, the word acute means like sharp, and so an acute angle less than 90 degrees, it makes like a lot sharper of an angle right here than this. Okay, this is kind of a little wider and spread out. This is like a sharper angle, and that's what acute basically means. Okay, here's a quick little example, or an example, and they're just going to ask you a couple of things. They want you to classify each of the angles that are given right here as right, acute, or obtuse. So let's take a look. Angle, that's the angle symbol, MJP. So let's find MJP. There's M, there's J, there's P. So let's do this in a different color. I'm talking about this angle right there, MJP. But it's already marked, isn't it? It's marked with this little yellow box. That little yellow box indicates that it's a right angle. So angle MJP is a right angle. That's all there is to it. Not that much figuring out to do. Look at this one, angle LJP. That's an L. Sometimes the angle symbol and the L's can be mixed up, but that's LJP. So find L, there's J, there's P. So what angle am I talking about? I'm talking about that angle right there. Now look, if from here to here was a 90-degree angle, that's more than a 90. So an angle that's more than 90 degrees has to be obtuse, from what we just learned a few seconds ago. What about this angle? This is NJP. Let me get rid of that blue thing. All right, NJP. There's N, there's J, and there's P. So I'm talking about this angle from there to there, and angle NJP. That's definitely less than 90 degrees, and so that would be an acute angle. So there's just a little demonstration of using that stuff. And that's what they'll do a lot of times. They're going to have picture, they're going to have several different angles all in one picture like this. Sometimes it gets a little confusing, but you just have to go by your letters, know how to label. It's very, very important to know how to label your angles so that you know what angle that specifically they're talking about. And notice, I also marked them, didn't I? You don't have to put arrows there, but I marked them so that I could see exactly which angle that I'm dealing with. If you really, really needed to and you weren't sure, you could always use a protractor and you could figure it out that way. So let me see if I can get that thing lined up. Let me scooch it about right there. Looks pretty good. If you look at this, this is about, what, 24 degrees? That's obtuse. Look at this. It hits it right on the 90, doesn't it? It's exactly a right angle. And this is, look, I went 90, 100, 110. It's probably about 113 or 14 or something like that. That's definitely an obtuse angle. Here's something that's pretty simple. I've got two angles here. I've got angle XYW and I've got ZYW, these two angles. Now look what's true about both of these angles. They're both 80 degrees. So they're both equal to each other. So in angles, we say that angles are congruent to each other. A lot of times in the book, you'll see it like this. They'll write a little M in front of it and they'll say the measure, that's what the little M is, the measure of angle XYW is equal, or a lot of times they'll say congruent to. Actually, when they say measure, they say equal. If they don't put the measure, they'll put the word congruent. To tell you the truth, it doesn't really matter to me. I'll probably rarely write this little M in front of it. I'll just say angle XYW is equal to angle, the measure of angle ZYW, ZYW, okay? You could say angle. If you didn't have the M's there, I wouldn't mind you just saying, so if they have equal measures, it means these angles are congruent to each other. So if you put a little squiggly thing, then that means they're congruent to each other. And how can I show that? I show congruent angles by putting a little arc on both of them. If this has one arc and this has one arc, then they're congruent to each other. What if I didn't even know that they were both 80 degrees? What if I didn't know either one of them? But all I saw was this little arc and this little arc. That automatically means these two angles are equal to each other. There's one thing I forgot to tell you. I was looking at the next example. I had it paused. And I have to tell you this, that if this ray right here, if you look at this ray, this is ray YW. That ray is YW. If it splits this big angle XYZ in two equal parts, which it does, this angle and this angle are equal to each other, we call this an angle bisector. So it's called an angle bisector. So what I would say is this. I would say ray YW, just like that, bisects, and we're going to use this quite a bit all throughout the book. YW bisects the whole big angle. What's the whole big angle? It's angle, let's make that angle look a little better. It's angle XYZ. Again, I could have called it angle ZYX, but make sure Y is always in the middle. So that's what it means to be an angle bisector. If it splits an angle, if you have a ray that splits an angle into two equal angles, two congruent angles, then we call that thing an angle bisector. Okay, here's the last example that we're going to do. I believe, yep, this is it. Here's the problem. This is right in the book. It says a figure, if K, in this figure, KJ, ray KJ and ray KM are opposite rays. So here's KJ, here's KM. They're opposite rays, which means this is a straight line right here. It says KN bisects. We just got done talking about that. Ray KN, let's find that. Here's KN. This one right here, okay, it bisects. In fact, let's do this to make it a little easier. Let's make that a different color. All right, so this ray right here bisects angle JKL. JKL is from here to here to here. This, or actually from JKL, same thing. It's this whole big angle right in here. So this red one bisects this whole big angle right here. If that's true, if that red one bisects, oopsie daisy, if, pushing wrong buttons here. If this red one bisects this whole big angle right here, that means that this angle here and this angle here are going to be congruent or equal to each other. So I could say that If this is the angle bisector, that means that these two angles have to be exactly the same if this bisects it. Bisects mean bi meaning two, splits it or dissects it, okay, splits it into two equal parts. So these two would be equal. Look what they tell you. They tell you that angle JKN, here's JKN. So they kind of tell you this angle right here, which is 8x minus 13. What else do they tell you? They tell you the measure of angle NKL. Let's find that. NKL, that's this angle right here. They tell you that that is 6x plus 11. And they ask you to find what angle JKN is, JKN. They want you to find this angle right here. I'm sorry, JKN, this angle, okay? They're trying to find this angle right here. Well, what am I going to have to do in order to find this angle? I'm going to have to solve for x. So I need to find a way to get x by itself. Then I can plug it in for this, and then I can figure out what this angle is. Well, what's the relationship between? Remember, this bisects it, so this angle and this angle are equal to each other. So this is the measure of the top angle, this is the measure of the bottom angle. They have to be the same. So algebraically, what are we going to do? We're going to set them equal to each other. So I take 8x minus 13, which is this angle, and I'm going to set it equal to 6x plus 11, which is this angle. Why do I set them equal? Because we were told that this was being bisected, so that means we've split this big angle into two equal angles. That's why I put the equal sign there. Let's do this quickly. Subtract 6x from both sides will give us 2x. Add a 13 to both sides, and that'll give us a 24. Divide by 2, and that'll give us x equals 12. That's not my answer, though. I have to find what angle JKN is equal to, JKN. So I have to put that x into this. So I'm going to go 8 times x, which we just found, which was 12, and then I'm going to subtract a 13. So 8 times 12 is 96. Minus 13, and what's that? That's 83. So that's 83 degrees. That means that this angle right here is 83 degrees. Without doing any other math, what is this angle right here going to be? Angle LKN or NKL. It has to be 83 degrees as well. And how do we know that? Because this big angle was being bisected, which means it split it into two equal angles. So if this is 83, that has to be 83. What if they ask you to find angle LKJ, the whole big thing, right? I know there's a lot of stuff all drawn in here. It looks a little messy, but what if they ask for that whole thing? Well, you got this 83 and you got this 83, so what do you do to the two to make the whole big angle? Okay, you add them up, right? So that'd be 166. So that blue one right there would be 166. All right, hope that makes sense, and we'll work on that next day in class.